Hey guys, and welcome back to another CATIA V5 tutorial. This one follows on from the previous wireframe and servicing tutorial where I showed you how to make a wing surface like this. Today what I'll be doing is I'll be taking you through to make the internal WingBox structures as well as a stringer. This is going to be encompassing most of the other operations you see in the GSD workbench. So through this tutorial I will be using aerospace related jargon and terminology, but I will be explaining myself, so I'm sorry if you do get a bit confused. So the first thing I'm going to create then is the spars, and the spars are the horizontal kind of components which go vertical and make up part of the wing box, or one of the big parts of the wing box. So the way I'm going to do that, or how we normally do it, is we define what percentage of the chord the front spar and the rear spar will take up. So to do that, usually it's in part of the design process, but normally for the front spar it's 10 to 15%, and the rear spar it's about 70 to 80% of the chord. And what I mean by that is from this point here to that point there, that length, 10% of it, which means it will be plonked there. So to do this then, I've created a new geometrical set called WingBox Surfs. So these will create, or this is what will make the actual surfaces. So first things first is to create the points between the two lines. So the way I'm going to do this is I'm going to create a point. I'm going to choose the point type as between. Again, one of these things that CATIA has is many options for all this. But I'm going to choose the between, and that basically says that you choose one point, you choose another point. In this case, it's going to be the origin, the x of my part. And then you can choose the ratio between them, i.e. in this case it's going to be 0.15, which is 15%. So just by doing that I get a point there which is 15% of this chord here. Click OK. Done and dusted. So do the other point then. I'm going to do it at the rear, at the very tip of the aircraft here, so the point there. But because I haven't got a point which is in direct line with it, i.e. along the x-axis, it's here, I'm going to, for point 2, create a point within a point. So we're getting an inception in this. So we're going to create a point which brings up exactly the same box. I'm going to use another between this and this, and I want it halfway, so 0.5. Okay. And that's my point 2, so you can see now that it's selected that as point 2, and there's my point there. And click OK. Oh. So there are my 2 points. All I have to do now is click on the line, and it will join them up. So that's the framework then for my front spar. And the good thing about this is because my leading edge is straight, I know that it's going to be 15% all along that span. Now to create the rear spar, because I've got a kink here, you can choose to do one of two things generally in aerospace design. One is to kink the rear spar and then bring it round, or to keep it nice and straight. Now for a bit of complexity to add to this, I'm going to have a kink in mind. So exactly the same way of doing this one here, only we need 3 points to define the kink. So exactly the same. So there we have the rear spar as well, exactly the same as the front spar, only with 3 points. So I've chosen a 0.75 or 75% of the chord as my rear spar, and that's what it gives me. So I've got 2 lines, which are 2 of the structural elements I need to make the actual surfaces. So to make the surfaces of the actual spars, what I'm going to do is I'm going to use the very simple extrude option. Now before you obviously do this for the rear spar, if you've done it in 2 points, you just need to make sure that you've joined them up, like I showed you in the first video. Join them up to make it into a single entity, otherwise it won't work as well. So now we've done that, we choose the extrude, we choose the profile. Now the direction that we want to do it is in the Z direction, because it's going straight up, so we choose that. So notice it's already started to pull it up. I don't want it at a certain length. What I want it is to go against this profile here. So instead I'm going with dimension, I'm going to choose an element, up to element. First one I'm going to choose is that. Now I'm also going to choose the other dimension as well, up to element, which is that, and you can see it goes up and it goes down, and it creates a line all the way down, a surface all the way down the wing, which is hugging the element, which is the skin. And that's it. That's how you make the surface for the spar. Exactly the same as well for the other one. Remember, if you haven't done a join, you need to make sure you do so, otherwise it won't work. Again, choose the Z component and choose the up to element, choose the skin, up to element, choose the skin. And that makes sure that we've got both of them within the WingBox. And that's as easy as it is. That's the spar. It's completely done. So we've got our spars defined now. So what we'll do now is define the ribs. So exactly the same way we made the spars with a line and extruding up to the skin. Same way as we'll do the ribs, only we'll make the lines in a slightly different way. So when I make the lines, I want my ribs to be perpendicular or 90 degrees to the rear spar, which is generally what you try and do. So I'm going to create lines which are 90 degrees, and the best way to do that is the way I'm going to show you. So first off, we create our points, and we choose the curve, i.e. the rear spar. Now you can choose one of three choices. You should really, for ribs, choose distance along a direction because it's swept. But for the sake of argument, I'm going to choose distance along curve because then I can use the repeat object after OK option. So I'm going to choose my length as 500 millimeters, preview it, nicely done. So I'm going to tick the repeat object after OK, click OK. So what it's done is it's created the point I wanted, and now it's asking me if I want to repeat it. So you can actually use this option freestanding in Wireframe. So what I'm going to do is I'm going to say I want to repeat this item, the point, along the curve 20 times at 500 millimeters each. Actually, we need 19 because we've got one already, and it's a 10-meter wingspan, so we need 20 in all. So press preview, the points come along the line, nice and easy. So it will create it in a new body, i.e. a new geometrical set in this case, because then it'll keep it nice and neat, because it's 20 points. It does actually make it quite a lot of, quite a bit in your design tree, so it just neatens it down a bit. So click OK. What it's saying here in the optional input, a reference point has been removed, i.e. this point here is not in the repeated objects, it's freestanding. That's just what it's telling you. It's not something that's gone wrong, it's just warning you about it. So there's our points defined now. So I'm going to use the line function to define my ribs. So with this one, I'm going to choose angle or normal to curve as my line type. Choose the rear spar and choose a point. The first one. You see it's got off as an angle, so I'm going to use a normal to curve function. Reverse the direction because I want to go that way. I'm going to ignore that one, which is basically saying where I'm going to start from. I want it to start from the point I am, but I want it to end on the front spar. So there we go, there's our line. Now, although it does say repeat object after OK, what it will do is just create a series of lines in the same place. So on this one, unfortunately, we have to do it the long way round. And press OK and do it one by one. However, if you press double click on the line icon, what you can do is you can work up quite a bit of a you can work through it quite quickly, like so. And there's all our rib lines defined. So because it wasn't a repeat object after OK addition, it hasn't put it into a geometrical set for us. So what I'm going to do is I'm going to highlight all the lines I just made. I'm going to go insert into geometrical set. So you see it's already put everything I've wanted there into it. So I'm just going to name rib lines. Close that down. It makes it nice and neat. So to create the ribs themselves, you use an extrude, and you choose each profile individually in the Z direction, and then choose up to element on each one, in order to create the ribs. So I'm going to go down the length of the wing. Again, it's not going to take a huge amount of time. If you double click it, you can make it quite quick, really. Right, so that's our WingBox surfaces done then. So in terms of the structural elements of a wing, that's all done. You can make an entire wing down to the minutest detail just with this structure here. Before I do that though, what I will do is I will split this skin up into sub-elements to allow me better control and ease of designing everything when it comes to it. So I'm going to split the skin into trailing edge, wing skins and leading edge. So the way I use that is the split function. Exactly the same way as you would do it in, for example, a solid, but you get a lot more options in this case. So what I'm going to do is I'm going to select the multi-section surface, which is the entire skin, and because of the way this has been done, I'm going to have to do several splits in order to get what I want. So what I want is a separate surface for the top, bottom trailing edge, top, bottom wing skin, and a single one for the leading edge. So if I choose that and I choose the cutting element to be the rear spar, you'll see it's already assumed that I want to keep everything on this side. Actually what I want to do is I want to do the other side. So what this will do is it will split it along that plane, but it will split it into two elements. So when I press OK, what it will ask me to do is to choose whether I want to keep one sub-element using a near operation, a sub-element using an extract operation, or to keep everything. And actually I want just the one skin. If I choose to keep all the sub-elements, it will have the top and the bottom skin in a single node on the tree, which is what I don't want. I want to have the bottom skin or the top skin on one single node in the tree. So what I'm going to do in this case is I'm going to use a near. So a near operation, which you can use, which is underneath, which is just here in the operations. And what this does is, as it says, it's going to choose something. I've got this selected at the moment. I want to keep the thing that is nearest to this line. So at the moment this is selecting the bottom skin because it is nearest to the line I just chose. Press OK, and that's it. I've got one skin under one node, which is under near 2, and that's the bottom trailing edge skin. You'll notice the entire other skin has gone away, but it hasn't, it's just been hidden, so I can re-show it, and I can hide that. And all it is from there is a matter of repeating it again. So split, choosing the multi-section surface, choosing the extrude again, and this time choosing a different element to keep it with a near. So I'm going to use a near operation again, and this time choosing that edge there to keep the top surface. So what I end up with is two surfaces, so the top and the top and the bottom skins of the trailing edge. So it's just a matter of repeating that until you have your 5 surfaces for the top and bottom. And once you've obviously completed it, the best thing to do is to go to Properties, Feature Properties, and just rename it. So in this case, it'll be the bottom trailing edge, just so you can keep a hold of it. So now I'm going to hide these two quickly. So hide both of these. And the same again for the wing skin, but the wing skin will be a little bit different due to the fact that you want something between these two posts here. So when you do your split, you choose your multi-section surface. How the cutting elements are now the rear spar, choosing the other side, and the front spar. So now you can see it split both of the sides off, and then I can continue on with my using a near. So I can use a near. I want to keep the bottom skin in this case, so I choose OK, and then choose a reference element as this. As it's closer, it chooses the bottom skin, and I'm left with the bottom skin as a single element. You'll notice when I do splits, if I was to choose, for example, go through it again and go to remove that one, if I choose the other side and then choose the front spar, you'll notice nothing happens. So it has to actually be the other side before it actually chooses, and I can't actually choose the other side now. So I need to remove that one choose the other side, and then go back to extrude. So if you ever get stuck, just be wary of that. CATIA does like you to do things in a kind of an orderly way, and if you don't do that, it kind of gets upset half the time. So all you got to do then is continue with that to get your top and bottom and then your leading edge skins. So there we have it. That's our wing skin. So we've got our 5 surfaces, all the rest are hidden. So what I'm going to do is I'm going to choose the other ones, the ones that I use to create them. Because I don't want to use them, I'm going to insert them into a geometrical set, call them build surfs, which go there. And now I'm left with, oddly in the middle, I don't know why it's done that, with my 5 panels that I need for this wing. Right, so lastly what I'm going to show you guys is how to make a stringer. So a stringer is a component which goes along the length of the wing and stiffens the skin, which means it can be quite difficult to make because skins generally don't stay the same shape. So the way we use this is with a sweep function, and I will show you quickly the profile of my stringer. So it's quite simple really. Here's my profile. It is quite important that the 2 bottom points here are coincident with either the skin or the sketch that made it, and that reason will become apparent in a second. So that's my profile. So what I'm going to do is I'm going to tell this CATIA to basically push or extrude that down the profile with reference to the skin. So when I'm going to do that, I'm going to make 2 lines to guide it, and I'm going to use the bottom points. I'm going to choose a point and a direction to do it, and my point will be the bottom one and my direction will be the front spar. So it's shooting off a line all the way down the wing, not in line with the skin, but that's fine for now. Press OK, do the other one, exactly the same again. So point, direction, 2 lines, and they're both outside the skin. So what I want to do is make these lines here coincident with the skin, and the way I'm going to do that is by projecting it. So projecting something, it will bring up this dialog box here. You can either do it along a direction, so you can choose which direction you want to actually project it across, or you can do it normal. And normal means it will just choose wherever the surface is normal to that point there. I'm going to choose, in this case, along a direction. So I'm going to project line 46. Support means surface in this case. And I'm going to choose the direction by right-clicking and choosing the Z component. Preview. And there we have our line is now conforming to the skin. Press OK. I'm just going to hide the line. Exactly the same again. Project this line using this support, using this direction, and OK. So there's our 2 guide lines which are now in direct contact, directly in or on the surface of the bottom skin. And because I've made the points coincident with the skin, I know that that line is now coincident to that point, which is why it's quite important to make sure that those 2 points are coincident with it. So now we're going to sweep it along. So opening the sweep function, this is where it gets very complicated. So sweeps have, or the sweep toolbar has 4 different types you can choose, and each type has several, if not more than several, ways you can do, or a subtype. So this is where it can get very complicated, but in this case what we're going to choose is we're going to choose the first profile type with 2 guide curves. So our profile is going to be the stringer, the guide curve is going to be one is going to be this curve here we projected, and the second one is going to be the other one we projected. Now you see it's got a computed anchor element, and anchor basically means where it's stuck to or stuck down, so it's going to keep it within this skin here. So press preview, and then we have it. It's as easy as that really. The stringer has gone down the length of the wing as far as we want it, and it's kept coincidence to it the entire length down. And if the wing does twist, it will twist the profile to match it, and that's exactly what you want for a stringer, which is why this one is so useful. Like I said, there's so many subtypes in here. You can do thousands of different things with sweep surfaces. This is just one of them. and with this you can make an entire wing stringer surface. So I'll end it there then. Hopefully you've learned today how to make the master surfaces for a wing. Next time what I'm going to do is I'm going to continue with surfaces a little bit. I'll show you how to make a wing tip to go on the end. I'll also be doing a bit more on sweeps, on how to create things such as propellers using things like lures. I will also going through how to change and modify something like this using the design tree and using the contextual menu to make it much easier. So please do tune in for that, and thank you very much for watching this video. Cheerio.